This video is brought to you by Firebreaker, an arcade-style VR shooter coming soon for the Oculus Rift. For more tips, behind the scenes, and to get your hands on Firebreaker's free downloadable demo, follow us on Twitter at Team Moonlight7 or on Facebook at facebook.com/Team Moonlight7. Links are in the description. Hello, I'm Derek Trong, lead programmer at Moonlight 7 Studios, and today I'm going to show you how you can get a single pool of objects running in Unity. For this tutorial, we're going to be using Unity 2018 and Visual Studio 2017, although you may use your preferred text editor. By the end of this tutorial, you'll know what object pools are, why they're so important, and how you can implement your very own in Unity. Object pools are a great way for intermediates and beginners to start pulling more performance out of their games, so let's begin, shall we? Don't you just hate load times? Everyone hates loading screens, but loading screens aren't the only spots where loading data can bog down your game's performance. That's right, sometimes games load data even during play, which can lead to lower frame rates and in the worst case, choppy gameplay during play. Beginner Unity developers often make this mistake without even realizing it through the overuse of two scripting functions. Instantiate and destroy are two functions used in script to load instances of game objects in the world and to unload them when they're no longer needed. Of course, use of these functions is necessary in order to create new instances of game objects during play. However, overuse of these functions leads to the game constantly loading and unloading data from memory, so it's best to minimize the use of these functions whenever possible. Object pooling allows us to reduce the number of times we call these functions by loading all of the objects we need at the beginning of the game in a pool and recycling them instead of destroying them. Objects in the pool are hidden from the player until an object needs to be used, at which point it is moved to an appropriate location in the world and then revealed to the player. When an object no longer needs to be used, instead of destroying it, it is returned to the pool so that it can be recycled. In this way, it becomes possible to only load objects at the start of the game, then reuse those objects that were returned to the pool instead of being unloaded by destroy. We just need to be mindful of which objects are used very many times so that we can pool them instead of destroying them. Projectiles like bullets are an excellent example of an object that is used very many times, so for this tutorial we're going to be pooling projectiles. Open up Unity and create a new Unity project. We're going to start by creating a projectile shooter much the same way a beginner would. Under Assets and create a new C# script and name it Projectile. Open up the script you've just created. We're going to write the basic code to move a projectile forwards. Add two public floats to the script, one to control the projectile's movement speed, and one to control how long the projectile lasts before it is destroyed. Add one private float to track the passage of time. In the start function, initialize the timer at 0 seconds. In update, track how much time has elapsed by adding time.delta time to the timer. Then check if the elapsed time has exceeded the self-destruct time of the projectile. If it has, then destroy the projectile. After that, we just write one line of code to move the projectile in its forward direction based off of the movement speed and the passage of time. This completes a basic projectile script that moves a projectile forward and destroys it after a certain amount of time. We'll be coming back to this script later after we set up our object pool. Back in Unity, under Object and 3D Object, create a sphere. This is going to be our projectile. I named mine Cannonball. Attach the projectile script to the sphere. Now drag the sphere into the asset window to turn it into a prefab. Since it's a prefab now, we can delete the sphere from the hierarchy. Next, we're going to create a script to fire the projectile. Create a new C# script called Cannon. This script will be used to spawn cannonballs at set time intervals. In the cannon script, create a public game object member to hold the prefab we want to spawn, and a public float member to set the time interval. Add a private float to track the passage of time, and in the start function initialize that timer to 0 seconds. Track the passage of time in the update function much in the same way as we did earlier in the projectile script. This time, after enough time has passed, instead of destroying this game object, we will be instantiating one of the prefabs. This script uses the variation of instantiate that sets the position and rotation. With this complete, we are now ready to set up our cannon in Unity. Under Game Object, 3D Object, create a cube and turn it 90 degrees so that we can see the projectiles when they're fired. Attach the cannon script to the cube. Now drag the cannonball from the asset window into the prefab slot of the cannon script. At this point, we can now play the scene and observe how the script behaves. As you can see, the cannon instantiates one cannonball every 2 seconds, and the cannonballs destroy themselves after a period of time. This is the functionality we were looking for. However, in its current state, cannonballs keep being loaded and unloaded from memory. Now let's actually set up our object pool. Under Assets and Create, create a new C# script and name it Single Object Pool. Open this new script. Now let's actually generate the pool. Start by creating a public game object to contain the prefab we intend to pool. Then create a public integer to determine the size of the pool. Lastly, create a private queue to actually contain the pool. In the start function, initialize the queue and write a for loop. For each iteration of the loop, we will instantiate one prefab and then add it to the queue. Now it's important to remember what functionality an object pool is meant to replace in Unity. We must be able to replace, instantiate, and destroy function calls in other scripts. In order to replace instantiate, we will be writing our own custom function called spawn. It will take a position and rotation because that is the variation of instantiate we are using. Spawn dequeues an object from the pool, sets it to a position and rotation, and enables it before putting it back in the queue at the end. This prepares the object to be recycled when the queue is exhausted and the object returns to the front of the queue. Now we must handle the destroy calls. For this, we will simply be disabling the game objects. Save the pool script and go back to the projectile script. In the projectile script, replace the destroy call with a command to disable the game object. Also, add an onEnable function in order to reset the timer when this game object is enabled. Lastly, go into the cannon script and replace the prefab with a reference to the object pool. Then replace the instantiate commands with the object pool spawn command. Now we're finally ready to hook up our scripts in Unity. Create an empty game object under the Game Object tab. Add the pool script to the game object, then drag in the cannonball as the prefab and set an appropriate pool size. Now drag this new game object with the object pool attached into the cannon script. That was the last step, so now we can appreciate the fruits of our labor. As you can see, our cannon has the same functionality as before. However, now, instead of continuously instantiating and destroying game objects, you can clearly see that objects in the pool are merely being turned on and off. And that concludes the tutorial. If you'd like to see more from us, be sure to follow us on Twitter or Facebook, and be sure to check out Firebreaker for Oculus Rift.